Hello everyone, this is the cloud bursting demo video. We will burst the workloads to Azure TDX. Cloud bursting is a configuration which is set up between on-premise clusters and public clouds to deal with peaks in IT demand. If it reaches 100% of on-premise cluster resource capacity, it will scale the workloads to a public cloud. Just like this picture shows, the pods are scaled gradually with workload increasing, and after it reaches 100% of on-premise cluster resource capacity, the new pod will be scaled to the public cloud. In today's demo, we will scale the pod following this logic. We will start running a new pod on-prem, and after the memory utilization of this pod reaches 70%, it will scale another new pod, and after, if there is insufficient memory to start a new pod, this new pod will be pending status, and at this situation, the pod will be scaled. We will scale a pod to the Azure cloud. So this is the full picture about this demo. The left part is the on-premise clusters. We assume that the on-premise clusters is in trusted environment. We deployed two clusters, cluster 1 and cluster 2. Cluster 1 will be used for running the workloads, and the cluster 2 will be used for running the trusted. The red part is the Azure public cloud. You can see that we set up the VPN between the on-premise clusters and Azure public cloud. So after there is insufficient resources to start the new pod, we will scale the pod to the public cloud, and the workload will be running in a confidential containers based on the TDX confidential VM. So it's also a peer pod confidential VM. Before we prepared a web application for this demo, and this application is encrypted. So to serve this HTTP web application, we need to decrypt this key using a key, and this key is stored in the KBS secret, trusted KBS secret. So it needs to retrieve this key from the trusted first before serving. So next I will show the process to retrieve this key. The container sends the request the key to the confidential data hub CDH, and then the CDH requests the key to the KBS. However, the KBS will only release this key after it gets the attestation token. So next, the attestation agent, it will send the evidence from the TE to the KBS, and the KBS will send the attestation request with evidence to the attestation service. After the attestation service verifies the evidence, it will send the attestation token to the KBS. Now the KBS gets the key and it will release the key to the CDH. And now the container could get the key and the application could be decrypted and can be served. So this is the whole process. Next, I will share the operators we installed. In the cluster 1, we installed the two operators, custom matrix autoscaler and OpenShift sandbox containers operator. A simple introduction about the custom matrix autoscaler. This operator is based on the Kubernetes event-driven autoscaler. This is the upstream project, and it's also called as KDA. It allows automatically increase or decrease the number of pods for deployment, stateful set, customer resource, or job, using additional matrix sources other than pods matrix. Another operator is OpenShift sandbox containers. We enabled the peer pods and confidential. Okay, this is the two operators we installed in the cluster 1. And on the cluster 2, we installed only one operator. It's confidential compute attestation. This operator will be used for the confidential workload attestation. Okay, next I will share the YAML files we will use for today's demo. Let's start from the on-prem deployment. Its count is deployment and the replicas is 1. So this means that we will start running one pod on-prem. And this deployment is labeled with my web app. And its container is using this one, a simple introduction about the image. It will start a HTTP server. When we send a HTTP request, it will return the number of the pod, the name of the pod which is handling the request. And at the same time, this server will allocate some memory at each request to simulate a memory intensive workload. So yeah, this is the configuration. Let's apply this YAML file. Okay, another YAML file is cloud deployment. The replicas is 0, no pod is running at the beginning, and its label is my web app, which is the same as the on-prem deployment. Here is we also define annotation, a clarification about it. This is used only for the debug purpose because the confidential containers doesn't allow users to log in the pod or get the logs. However, we will show the logs in today's demo. That's why we add this item. And the runtime class name is Kata Remote. And also in the container, you can see we are using the same image with on-prem deployment. So let's apply this YAML file. And we also define a service to expose the network application, which is running as both on-prem pods and cloud pods, which are labeled with my web app. Let's apply the service YAML file. We also defined a route to host the application at a public URL. Let's apply it. Okay, next I will share the two skill policy files. The first one is memory skilled object. The purpose of this file is that once the memory utilization reaches 70%, we will scale a pod on-prem. To be specific, the on-prem deployment, the replica will increase 1. Let's apply it. The second policy file is that we are scheduling the pod following the pod status. If there are pods which named with on-prem deployment, if there is one pod unschedulable, and then we will scale the pod to the cloud. So to be specific, the replica number of cloud deployment will increase 1. Let's create this policy. Okay, now we have deployed the deployments and its policies ready. Let's start running the workloads. Before running the workloads, I will give a simple introduction about the 3 windows. This is the terminal. We will start running the workloads, and this window is the pod page of the OpenShift cluster 1, and this page it's a Microsoft Azure Web Console, and this you can see it shows the VM. Let's refresh this page. So before the workload running, there is no VMs here. Okay, after the pod is skilled to Azure, which means a peer pod VM is running in Azure, then we will say a VM here. Okay, next let's start running the workloads. As I have introduced about the image, so the image, it will start a HTTP server, and when we send the HTTP request, it will return the name of the pod which is handling the request. And at the same time, the server will allocate some memory at each request to simulate a memory intensive workload. So currently, as it's at the beginning, we have one pod is handling the HTTP request. This one, and we can see the pod in this page here. After the memory utilization reaches 70% of this pod, then we will say a new pod will be scaled on-prem. So yeah, here we can say a new pod is running now. This one, yeah, it's end with M, and here we can see that this pod is handling the requests also. This is the request number, and after the memory utilization of both pods reaches 70%, then the third pod will be scaled. And here we will say the third pod will be running. Here we can see the third pod. However, it's pending status. Let's check the pending reason. The pod unschedulable. Zero pod. Sorry. Because the cloud deployment is scaled. So let's continue the reason. It's zero pods are available. It's because insufficient memory. Okay, so here is a cloud deployment. It's let's check the Azure, the Microsoft Azure web page. Let's refresh this page again. Here we can see pod VM is running, and its size is standard DC2 EDS v5. This is the TDX confidential VM size. The pod is in this pod is in pod initializing phase. Okay, it's running now. And let's check the workloads here. Here we can see that the cloud deployment is handling the requests too. So now we actually have 3 pods handling the HTTP request, 2 pods on-prem, and 1 pod in the Azure cloud. Next, let's check the logs of the cloud deployment. Here we can see the attestation process, the process to retrieve the key from the KBS. Here is the logs. This is the application. It's app attestation, and next is fetching the key from the trustee using the cur command. Gets the key.bin. And next is decrypting the workload. It's using this command to decrypt this encrypted file. And this is the key, and the file decrypted successfully. So this is a logs which shows that the container requests the key from the KBS, and it gets the key, and the file is decrypted successfully. Next, let's check the logs of the trustee. Let's scroll down to the bottom, and so here is the log. You can see the AZ TDX VTPM for endorsement check passed, and it gets resource from the KBS. Resource access request passes policy check. So this log shows that the KBS, the container retrieved the key, and get the key from the KBS successfully. That's all. Thank you.